Good morning, everyone. This is Sachin Fiske from Electrical Engineering Department, SND College of Engineering and Research Center. In the today's lecture, we are going to discuss about the architecture of SCADA system. In this section, we are going to details which subscribe the common architecture required for the SCADA product. Here, some hardware architecture is given. The basic hardware of the SCADA system is distinguished into two basic layers. The client layer, which caters for the main machine interaction, and the data server layer, which handles most of the process data controls activities. The data serve communicate with the device in the field through process controllers. Process controller, for example, the PLCs are connected to the data servers either directly or via network or field bus that are proprietary, that is Siemens HI, or non-proprietary, for example, Profibus. Data servers are connected to each other and to client station via an Ethernet LAN. This figure shows the typical hardware architecture. Now, the software architecture. The SCADA products are multitasking and are based upon a real-time database, that is RTDB, located in one or more servers. Servers are responsible for data acquisition and handling like polling controllers, alarm checking, calculation, logging, and archiving on a set of parameters, typically to which those are connected. However, it is possible to have a dedicated server for particular tasks, for example, historian or data logger or alarm handler. A SCADA architecture that can be a genetic for the product. Now here is the description about the communication of this architecture. So internal communication is the server client and server communication is in general on a publish subscribe and event driven basis and uses a TCP IP protocol, that is a client application subscribes to a parameter which is owned by a particular server application, and only changes to that parameter are often then communicated to the client application. Then access to device. The data server pulls the controller at user defined polling rate. The polling rate may be different for different parameters. The controller passes the requested parameter to the data server. Then timing stamping of the process parameter is typically performed in the controller, and this timestamp is taken over by the data server. If the controller and communication protocol used supports unsolicited data transfer, then the product will support these too. The product provides communication drivers for most of the common PLC and widely used field bus. For example, Modbus. Of the three field bus that are recommended are both Profibus and WorldFib are supported, but Canvas often not. Some of the drivers are based on a third-party product, for example, Applicom cards, and therefore have additional cost associated with them. VME, on the other hand, is generally not supported. A single data server can support a multiple communication protocols. It can generally support as many such protocols as it has the slots for interface cards. The effort required to develop a new drivers is typically in the range of 2 to 6 weeks, depending on the complexity and similarities with existing drivers, and a driver developed toolkit is provided for this. There is some classification based on the generation. The first one is first generation, that is monolithic. The first generation, the computing was done by mainframe system. The network didn't exist at the time SCADA was developed, and thus SCADA system were independent systems with no connectivity to the other system. Wide area network, that is WAN, later designed by RTU vendors to communicate with the RTU. The communication protocols used were often proprietary at that time. The first generation SCADA system was the reductant, since the backup mainframe system was connected at the bus level and was used in the event of failure of the primary mainframe system. Then second generation is distributed. The processing was distributed across multiple stations which were connected through a LAN, and they shared information in the real time. Each station was responsible for a particular task, thus making the size and cost of each station less than one used in the first generation. The network protocol used were still mostly proprietary, which leads to significant security problem for any SCADA system that received the attention from a hacker. Since the protocol were the proprietary, a very few people beyond the developer and hacker knew enough to determine how secure a SCADA installation was. And since both the parties has vested the interest in keeping the security issue quiet. Then the third generation is a network generation. There are the current generation SCADA system which use the open system architecture rather than a vendor controlled proprietary environment. The SCADA system utilizes open standard and protocols, thus distributing the functionality across a wide area network rather than a local area network. It is easier to connect the third-party peripheral devices like printer, disk drive, and tab drive due to use of the open architecture. Wide area network protocols such as Ethernet protocol are used for communication between the master station and communication equipment. And due to the use of standard protocols and the fact that many network SCADA systems are accessible from the internet, the system are potentially vulnerable to remote cyber attack. On the other hand, the uses of standard protocol and security techniques means that the standard security improvements are available applicable to the SCADA system, assuming they receive the time mainly and updates. A human machine interface or HMI is the apparatus which presents the process data to the human operator and through which the human operator controls the process. An HMI is usually linked to the SCADA system database and software program to provide the trending, diagnostic the data, and management information such as the schedule maintenance procedures, logistic information, and detailed schematic for a particular sensor or machine and expert system troubleshooting guides. The HMI system usually presents the information to the operating personnel graphically in the form of a mimic diagram. This means that the operator can see a schematic representation of the plant being controlled. For example, a picture of a pump connected to a pipe can show the operator that the pump is running and how much fluid is pumping to the pipe at the moment.